Amortization is the process of paying off a loan. So let's look at the mathematics of loans. In a previous video, I mentioned that you could purchase an annuity, wherein you give the bank a large sum of money and they provide you with monthly payments. This seems like a loan, but in reverse. And indeed, a loan is mathematically equivalent to the bank purchasing an annuity from you. So let's start with a simple example. Let's suppose that you purchase a $900,000 home with a 20% down payment, financed at 2% APR monthly over 25 years. What are your monthly mortgage payments? This is a reasonable question. So with a 20% down payment, that means that the value of the loan is 80% of the purchase value of the home, or $720,000. This is the value of the annuity today, so it represents the present value. And if we take everything and we throw it into our formula, we have a term rate of 2% divided by 12 months over 12 times 25, or 300 payments. Solving this for R gives us $3,051.75. Now this is a straightforward but important example. Let's do something now a little bit more complicated. Let's use the same mortgage as above, but this time we're going to refinance at the 15-year mark using the same rate, but for an additional 15 years, say, instead of the original 10 years that we would have done. Refinancing means that we're going to take the amount that we currently owe on the house and we're going to create a new mortgage out of it. So A, how much are the monthly payments after you refinance the house? And B, how much more interest do you pay as a result of this refinancing process? So the timeline here won't be important, but it'll serve as a nice visual aid, so I'm going to include it anyway. Each tick mark is going to be 5 years, and we know that we're going to refinance at the 15-year mark. We already know the value of a loan is the present value of the annuity, and this is still true at the 15-year mark as well. The amount remaining on the loan is its present value, only now the present is at the 15-year mark. As our 10 remaining years on the original loan, that's 120 more payments. So if we throw everything into our present value formula, but this time use an exponent of 120, that's going to give us this value, $331,663.75. So this is the amount we still owe on the house, so we can calculate the new monthly payments by pretending that we are taking out a new mortgage. We're going to use the same formula as in our previous example, except instead of $720,000, we use a $331,000 value above, and we use 150 payments this time. And so working this out gives us $2,134.28, which is significantly less. Now for part B, we need to know how much interest we would have paid had we not refinanced. Pause the video and see if you can figure out what this number should be. So the total interest paid is the total amount of money we pay less the amount of the original loan. There were 300 total payments at $3,051.75. The original loan was $720,000, so that works out to $195,525 in interest. Now for the interest paid in the first 15 months, we need to know how much of the principal we paid off, namely what is our equity in the house. The equity is the difference in the original loan value and what we still owe on the loan after 15 years. The original loan is $720, we still owe $331, so our equity is about $388,000. The interest paid is the same as the calculation above, except we only made 150 payments at $351.75. So if we do this and we subtract our equity from the total paid, then we're going to get about $160,000. For the second part of the loan, after we've refinanced, we made 15 times 12 equals 160 payments at $2,134.38. So if we then subtract our total equity of the loan, that gives us another $52,000. So the total interest is thus the sum of these two numbers, and you can add them up, you get about $213,000. If we subtract what we would have paid in interest, that gives us about $18,000 more paid as a result of refinancing the loan.